Hi students, yesterday we discussed about crystal structures. After completion of crystal structure, we are going to the next topic is Bravis lattices. So here two words are there. The first word is Bravis. Bravis is nothing but this is the name of the scientist. This scientist explained about lattices. Generally, according to our basic term, lattice is nothing but which is called as a space lattice. Lattice is nothing but space lattice. This space lattice always we are explaining in three-dimensional point of view. So, three-dimensional point of view, any crystal can be explained on the basis of Bravis lattices. On the basis of Bravis lattices. These Bravis lattices are introduced in 1880 by Bravis. Clearly explain the structures of the crystal in three-dimensional point of view. So, Bravis lattices simply called as Bravis space lattices. According to Bravis space lattices, here explain the complete crystal structures. Complete crystal structures, especially you also learned about crystal systems. These crystal systems entire nature, they have only 7 crystal systems are there. According to their structure, all crystals are converted into their crystal systems. Totally in nature, there existing 7 crystal structures. So these 7 crystal structures are explained with respect to two-dimensional point of view. These crystal systems are explained with respect to two-dimensional point of view. But according to the Bravis in 1820, he clearly explained the crystal systems are converted into totally 14 crystal systems. 14 Bravis lattices are there with respect to three-dimensional point of view. So, in this way, entire nature, any crystal is there, that crystal structure must be existed out of these 14. Any one of the structure out of these 14 structures. So, these 14 structures, what are those structures? Nothing but. So, this Bravis lattice, according to the Bravis lattice, you can clearly explain the crystal systems. Already we know that 7 crystal systems are there. According to what are those 7 crystal systems, sir? Those are very easily identified by using the statement is C. Tom is a teacher. He teaches Hindi. That is the statement. C. Tom is a teacher. He teaches Hindi. Based on this C is nothing but cubic structure. Cubic structure. T is nothing but tetragonal structure. O is nothing but orthorhombic structure. M is nothing but monoclinic structure. Next, T is nothing but trigonal structure. Again, T is nothing but what is the next T? Hexagonal, and the next T is monoclinic. After that monoclinic, again clinic is there, that is called as triclinic structure. Both clinics are coming side by side. After triclinic, next one is trigonal structure, and the last one is hexagonal structure. These are the 7 crystal structure. According to their lattice parameters, we are divided into 7 crystal structures. According to basic on lattice parameter. What are the lattice parameters? According to axial length ABC, according to their interfacial angles alpha, beta, gamma. So their conditions are cubic structure is nothing but A equal to B equal to C, and alpha equal to beta equal to gamma equal to must be 90 degrees. Tetragonal structure is nothing but A equal to B and is not equal to C. Alpha equal to beta equal to gamma must be 90 degrees. Orthorhombic structure is nothing but A is not equal to B and not equal to C, and alpha equal to beta equal to gamma must be 90 degrees. After that, monoclinic structure condition is A is not equal to B, not equal to C, and alpha equal to beta must be 90 degrees and not equal to gamma. And triclinic structure, A is not equal to B, not equal to C, and alpha not equal to beta, not equal to gamma must be 90 degrees. Must be not equal to 90 degrees. And trigonal structure, A is equal to B equal to C, and alpha equal to beta equal to gamma must be not equal to 90 degrees. Hexagonal structure is nothing but A is equal to B and is not equal to C, and alpha equal to beta must be 90 degrees and gamma value is equal to 120 degrees. These are the structures. These are the structures according to crystal structures, their lattice parameter conditions. According to the Bravais, these two-dimensional crystal structures can be explained in terms of three-dimensional point of view. These three-dimensional point of view, these 7 crystal structures are converted into 14 Bravis lattices. With respect to three-dimensional point of view, these 7 crystal structures can be converted into 14 Bravis lattices. What are those? Bravis lattices. Bravis lattice number. In cubic structure, these are totally 7 structures. According to three-dimensional point of view, cubic structure has 3 Bravis lattices. Tetrahedral structure has 2 Bravis lattices. Orthorhombic has 4 Bravis lattices. Monoclinic has 2 Bravis lattices. Triclinic only 1. Trigonal only 1 Bravis lattice. Hexagonal only 1 Bravis lattice. Totally 3 to 5, 5 plus 4 9, 9 plus 2 11, 12, 13, 14. These are the 14 Bravis lattices. So according to three-dimensional point of view, Bravis lattices are converted into 14 types. Those are, these are nothing but, according to three-dimensional point of view, every cubic structure has 3 Bravis lattices. What are those? According to the structural arrangement, what are those? What are those? Nothing but, according to Bravis lattice, these 3 Bravis lattices is nothing but, one is simple cubic structure, second one is face center cubic structure, third one is body center cubic structure. And tetragonal structure has one is only 2, one is simple cubic and second one is base, second one is and second one is body center cubic structure. And orthorhombic has totally 4 structures. One is simple cubic, second one is face centered cubic, third one is body centered cubic, and fourth one is base center cubic structure. And monoclinic structure has only 2 Bravis lattices, that is, one is simple cubic, second one is base centered cubic structure. Here last 3, triclinic, trigonal and hexagonal, has only 1 Bravis lattice, that is called as simple cubic structure. That is called as simple cubic structure. These 14 Bravis lattices. So according to the Bravis lattices, these structures can be drawn or can be explained with respect to three-dimensional point of view. Three-dimensional point of view is nothing but you can explain these structures with respect to in the space. Anywhere you can explain the structures. So these crystal systems are explained with respect to two-dimensional point of view. These 14 structures are explained with respect to three-dimensional point of view. So these 7 structures, otherwise these 14 structures, according to their lattice parameters, the structural conditions does not change. These are the main conditions. Based on these conditions, you can draw these structures: simple cubic, body centered, face centered, and base centered. So entire 14 structures, mainly 4 structures are repeated. One is simple cubic, another one is face centered cubic structure, and another one is body centered cubic structure, and last one is base centered cubic structure. What are those? How these structures are drawn? Seen one by one. So first write down very clearly, note down. So those are the 14 Bravis lattices. How to draw these 14 structures? You can learn one by one. So according to out of 14 structures, some structures, mainly 4 structures are repeated out of 14 structures. One is simple cubic structure. This simple cubic structure is simply called as primitive cell. Already this primitive cell topic is covered in first class. SSB first class, otherwise second class, I know. So what is primitive cell? Primitive cell is nothing but first of all a unit cell. Primitive cell is nothing but first of all a unit cell. What is a unit cell? You can take very smallest geometrical structure of the crystal. That crystal smallest structure is repeated, they give the complete structure. That smallest geometrical portion can be called as unit cell. Particularly this unit cell has lattice points. Unit cell has lattice points at their corners. At their corners of the unit cell. Then that unit cell can be called as primitive cell. According to our Bravais structures, this primitive cell simply called as a cubic structure. This primitive cell is simply called as a cubic structure. What is simple cubic? Suppose I am drawing one cubic structure. So this is the cube. This is the cube. According to the cubic structure, they have how many faces are there? Total number of faces in cubic structure is 6. And how many corners are there? Entire the cubic structure they have 8 corners. How many body centers are there? Body center. How many centers are there? Particularly one cubic structure has one body center are there. So you can take the corners number. So first of all I am corner. So this can be taken as O, A, B, C, D, E, F, G. I am giving the lettering to the cube. So according to, they have 8 corners are there. So what are those corners? According to structure is that point can be taken as corner, starting with O. O is one corner, A corner, B corner, C, D, E, F and G. So totally 8 corners are there. That corners are representing by using the lettering. This lettering is existed, that is the corner of the cube. In a similar way, what is the, how many faces are there? There are totally 6 faces are there. So first I am drawing first face. Front face. Front face is E, F, G, D. This is called as front face. Second one. After completion of front face, I am drawing the exactly opposite face, that is back face. That back face is O, A, B, C. This is exactly back side of the face. Back face. Next, front and back is completed. I am representing right side face. Right side face is F, A, B, G. B, G. This is called as right side face. So, what is the opposite version of right is nothing but left side face. So, I am drawing the left side face is O, C, D, E. O, C, D, E. This is called as left face. So, front, back, left and right is completed. So, next face can be taken as top face. This is the top face. D, B, C, D, G. B, C, D, G, which is called as top face. Bottom face. O, A, F, E. O, A, F, E, which is called as bottom face. So, totally they have, how many faces are there? Totally 6 faces are, these are the 6 faces. So, this cubic structure best example is our classroom. So, our classroom can be taken as example. Floor is one face, slab is another face, down and top face. And towards right, one wall is there, that is right face. Exactly left hand side, one wall is there, that is called as second. 1, 2, 3, 4. Remaining, one is blackboard or whiteboard face, other one is back side, classroom back wall is called as sixth face. That is called as totally 6 faces are there. This is the 6th face. So faces are 6 completed, corners 8 completed. Exactly what is that? Body centered. So exactly our classroom has each and every person existed with respect to the faces or corners. Exactly middle point of the room. That is nothing but that room point, middle point of the room, exactly middle. So you can represent it like this. This pen can be taken as exactly middle point of the room. This room point, this is in the air, nothing but space. We are not. So may I showing cross. This cross point indicating body center point. That face is called as body center face. So first of all, what the structure I am representing? Simple cubic, otherwise primitive cell. Primitive cell or simple cubic structure is represented by letter capital P. So enter the crystal structure. The structure P is written on the paper. This P structure is nothing but simple cubic or primitive cell. So primitive cell or simple cubic structure is represented by letter capital P. How they write it? The structure of simple cubic structure. So you can take the one smallest structure of the entire crystal. So I am taking the cubic structure like this. This cubic structure has how many corners are there? Totally 8 corners are there. 8 corners are occupied by the lattice points, nothing but like this. First corner, second corner, third corner, fourth corner, fifth one, sixth one, seventh one, and eighth one. So each and every corner is occupied by lattice point. Then the structure can be called as simple cubic structure or primitive cell. So simple cubic structure, what is that? Primitive cell. That is the unit cell. That unit cell consisting of the lattice points at their corners. Then that complete structure is called as primitive cell. That is the first Bravis lattice, simple cubic structure. And the second one is face center cubic structure, which is represented by FCC by using the lettering is capital F. So that capital F structure is nothing but face centered cubic structure. So this face centered cubic structure is first of all simple cubic structure. Face centered cubic structure, first of all a simple cubic structure. What is simple cubic structure? Every corner is occupied by lattice point, then the structure is called as simple. So I am drawing the first simple cubic structure. So all corners are occupied by lattice point, that is called as primitive cell or simple cubic structure. So face centered cubic structure is first of all a simple cubic structure. So I am drawing the simple cubic structure. Enter the cubic structure. How many faces are there? Totally 6 faces are there. Every center of the face occupied by one lattice point. Here how many faces are there? Totally 6 faces are there. So every lattice point, every face center occupied by one lattice point. So I am showing the first top face. So diagonal contact point, you can take it like this. Where the diagonals are contacted, that is called as center of the face. I am represented by lattice point. So this is, that is the top face. In a similar fashion, bottom face. So this is the contact point, this is lattice point. Left side face. So this one. Right side face. So this is contact point. So top, bottom, left and right faces are completed. What next? Back face and front face are there. Back face. So this is back face. These 2 points are contacted. That back face is represented, the center is this one. In a similar way, front face. This face center diagonal may be here. That structure is called as face centered cubic structure. So what is the face centered cubic structure? Face centered cubic structure, first of all a simple cubic, and face centered cubic structure is first of all a simple cubic structure, and every center of the face is occupied with one lattice point at the center of every face. Then the structure is called as face centered cubic structure. So out of 14 Bravis lattices, mainly 4 structures are repeated. One is simple cubic, second one is face centered cubic structure, third one is body centered cubic structure, and fourth one is base centered cubic structure. Simple cubic structure is represented by letter capital P. Face centered cubic structure is represented by letter capital F. What next? Next one is body centered cubic structure. You can draw that one. Enter.
24 minutes. Daddy, ఒకసారి మార్క్ చేయరా? నాకు డ్రా చేయడం వచ్చి 3D పిక్చర్. కానీ ఇలా డ్రా చేస్తే వస్తుందో రాదో అని చెప్పి. మాకు వచ్చాడు అదే సరిగ్గా 23 minutes అవుతుంది. ఆగు మమ్మీ. ఇదిగో.
ఏమైందమ్మా?
అందులో ఎంత ఉన్నాయో చూసుకో. చూస్తే ఎంత ఉన్నాయో 400 ఉన్నాయి.
సరే రా రా రా.
3, 2, 1.
Center cubic structure. Body centered cubic structure, which is represented by BCC. Which is represented by BCC. In a letter point of view, this is represented by capital B. So where is the B is existed? The structure is called as body centered cubic structure. So first of all, this structure is drawn by using one cubic structure like this. So this is cubic structure. This is cubic structure. So what is BCC? BCC is nothing but, first of all, it is a simple cubic structure. BCC structure is nothing but, first of all, a simple cubic structure. Simple cubic structure is nothing but primitive cell. What is primitive cell? Primitive cell, first of all, a unit cell which consisting of lattice point at every corner of the structure. So here how many corners are there? 8 corners are there. 8 corners are occupied by 8 lattice points. So this is 8 corners are occupied by 8 lattice points. So this is a primitive cell or simple cubic structure. So a body centered cubic structure is first of all a simple cubic structure. How this simple cubic structure is converted into body centered is nothing but, every cubic structure has how many body centers are there? Only one body center is there. That body center is occurred this point. So what is the center of the body? How to draw it? So how to draw it is nothing but, you can take the exactly opposite corners. So according to our classroom, you can take any one of the corner on the top. So the top point and bottom of the opposite corner, this is the exact one diagonal. In a similar fashion, top diagonal and bottom diagonal, these two are contacted at particular point, that is called as center of the body. So here center of the body is there. So this is part 1, bottom, top, bottom. You can draw it like this. The contact point, this is center of the body. The center of the body is occupied by one lattice point. Then that structure is called as body centered cubic structure, which is represented by capital B. And fourth one, the structure is base centered cubic structure. Base centered cubic structure. This is not represented by like as BCC, FCC and SC. So this is, according to letter point of view, this is represented by capital C. Capital C is nothing but base centered cubic structure. This base centered cubic structure is first of all a simple cubic structure. Hold up. This is first of all a simple cubic structure. What is simple cubic structure? Simple cubic structure is nothing but primitive cell. What is primitive cell? Primitive cell is nothing but a unit cell. That cell consisting of lattice point at every corner of the structure. So I am taking one cubic structure like this. This is the cubic structure. In this cubic structure, how many corners are there? Totally 8 corners are there. So 8 corners are occupied by 8 lattice points. So base centered cubic is first of all a simple cubic structure. So this is simple cubic structure. 8 corners are occupied by 8 lattice points. So here you are explained base. Suppose you can take any one of the cube. That cube is placed on the table. One is base like this. Suppose you can consider this is the cube. This cube is placed on the hand. So this bottom face can act as the base of the cubic structure. Suppose this one. Top face is placed on the hand. So this top face is acting on the base. Suppose you can take any one of the other cube. Suppose this is the one cube I am placing on the hand. So this bottom face acts as a base of the cubic structure. Another cube is also placed like this. So this top face is act as the base of the cube. So entire cubic structure, how many bases acting? There are two bases are acting. What are those? Bottom and top faces can act as the base. So bottom face, the diagonal contact point, nothing but this is the base center. So every base center occupied by one lattice point. Then cubic structure is called as a base centered cubic structure. So out of 14 structure, mainly these 4 structures are repeated. So according to these structures, you can maintain the conditions. What are the conditions? In crystal structure, they have first cube structure is cubic structure. Second one is tetrahedral structure. Third one is orthorhombic. Fourth one is monoclinic, triclinic, trigonal and hexagonal. These are the 7 crystal structures. These 7 crystal structures are converted into 14 Bravis lattices. What are those? Cubic structure have 3 Bravis lattices, tetrahedral structure 2 Bravis lattices, orthorhombic 4, monoclinic 2, triclinic 1, trigonal 1, hexagonal 1. So based on these 3 structures, cubic is nothing but simple cubic, face centered, body centered. Tetrahedral nothing but primitive cell, base centered. Orthorhombic primitive cell, face centered, body centered and face base centered. Monoclinic primitive cell and base centered. Triclinic primitive, trigonal primitive, hexagonal primitive. So these are the structures. Based on the structures, you can draw the condition. What are the conditions? Cubic structure conditions are A equal to B equal to C and alpha equal to beta equal to gamma must be 90 degrees. You can maintain the lattice parameter condition. You can draw 3 structures. You can draw 3 structures. And next, tetrahedral or tetragonal. A equal to B not equal to C, alpha equal to beta equal to gamma must be 90 degrees. And orthorhombic, A is not equal to B, not equal to C, equal to 90 degrees. What is the monoclinic structure? A is not equal to B, not equal to C, alpha equal to beta must be 90 degrees and not equal to gamma. What is triclinic? A is not equal to B, not equal to C, alpha not equal to beta, not equal to gamma, not equal to 90 degrees. And what is trigonal? A equal to B equal to C, alpha equal to beta equal to gamma equal to not equal to 90 degrees. And hexagonal, A equal to B and is not equal to C, and alpha equal to beta must be perpendicular, and third one gamma must be equal to 120 degrees. Maintain these lattice parameter conditions. You can draw 14 Bravis lattices. So you can try it. Otherwise, you can ask me how to draw it. I will explain to you. Note down the